Today is a good day to talk about the time value of money. Now, traditionally, this topic is introduced in a finance class. In fact, I hope you've had previous exposure to it in other courses. So why then are we covering this in accounting data analytics? Let me give you two good reasons. Number one, I think it fits quite nicely in our overview of Excel functions. When you do time value of money calculations in the future, you're probably going to be doing it in Excel. So let's take some time and get comfortable with those functions today. Number two, I just think the topic is so dang useful. I don't think you can get too much of it in a business school education. Sometimes when you're in class, sitting and learning about a new topic, you wonder to yourself if and when you'll ever use that knowledge. Not so with the time value of money. Now, I'm not saying that I use these calculations every day of my life, but when I've needed to, it has helped save me a lot of money, and I hope that could be the case for you too. My goal with this video and this part of the course is not to give a thorough treatment of the topic. We're going to keep things pretty basic. Again, I hope you've had previous exposure to this topic, and in that case, it'll be a good review for you. But if not, we're going to keep things pretty manageable. So let's dive in. If you've had some previous exposure to the time value of money, you might have heard it described as saying that a dollar today is worth more than a dollar tomorrow. More precisely, this concept gets at how money in the present is worth more than the exact same amount of money in some future period. And it's critically important to understand why that is. I will suggest three primary reasons. Number one, inflation. In recent years, it's been pretty apparent that even over short periods, inflation can reduce the purchasing power of your hard-earned money. Now, while there may be times when prices decline over a period, by and large, costs tend to go up over time, not down. Number two, opportunity costs, which refer to benefits you sacrifice in pursuit of an alternative. You can't spend or otherwise use or invest money that's tied up until some future period. So that's part of those opportunity costs, why you'd prefer to have a dollar today. And then lastly, risk. Risk can take many forms, but we'll keep it simple and describe it as basically saying that the future is uncertain. You just don't know for sure what tomorrow will bring. And so, a dollar in the hand is worth two in the bush. Let's review those 3 points again with a thought exercise. A hypothetical example to illustrate how these forces make it so that a dollar today is worth more than a dollar in the future. Would you be willing to give a good friend a $1,000 loan with no interest attached if they promise to pay it back in, say, 30 years from today? Well, unless you are a very generous and wealthy friend, I doubt it. But why? Pause the video for a minute and try to come up with a few reasons why this loan doesn't make good financial sense, using the 3 factors from the previous slide. Okay, well, for one, your money's purchasing power is going to decline with inflation. Even with a modest inflation rate, your money isn't going to go half as far in 30 years as it would today. Which brings us to the second point, opportunity costs. I don't know what your friend is going to be doing with your money for all those years, but it is certain that you won't be able to put that money to productive use. Not only do you miss out on potential financial returns on investment, you could have invested it in the stock market or put it in a CD account, earning some dividends or interest. But you also miss out on being able to use that money for your own consumption. Every day that dollar's not being put to use in the way you want, that's an opportunity cost. And lastly, you also face the risk that you may never see that money again. You can't know for certain what your friend's financial situation will look like in 30 years, and you don't know what life events could impact their ability to repay the loan. I also want to give you a sense of the importance of being able to do these calculations as an accountant. There are several topics in both financial and managerial accounting that require a working knowledge of the time value of money. Let's take lease accounting, for example. Delta Airlines has a fleet of roughly 1,000 aircraft, many of which are leased. And these lease agreements can last as long as a decade, with annual payments in the billions of dollars. Now, when Delta has to talk to its shareholders and disclose the size of its lease liability, well, they're not going to just add up all those payments they owe in the future and put that on the balance sheet. Nah, they'll get hammered on their debt ratios. They're going to express their future obligations in terms of how much those collective lease payments are worth in today's terms. From a managerial perspective, let's take the Disney company. When management over their amusement parks division is thinking about adding a new roller coaster, believe me, they are not thinking about costs and benefits on a one-year horizon. Their capital budgeting procedures are going to involve both how much they'll have to expend today and how much this will impact the company's cash inflows for many years down the road. Now, there are many other accounting applications of the time value of money, such as bonds, investments, and others. This is a pervasive topic. And beyond simply being better accountants, having a solid understanding of the time value of money is going to make your life better. When it comes to looking at various options when buying a car or a home, you want to come to the table understanding interest rates better than the salesperson or realtor you're talking to. Knowing the time value of money will help you be more confident as you plan for retirement. So like I said before, I'm not making the claim this is something you'll use every day, but the days of your life when this material is relevant will be some of the most important, financially speaking. Okay, so let's get to the nuts and bolts then. When you're working through a time value of money problem, you start by identifying the parameter you're trying to solve for. For example, you might be trying to calculate what your monthly mortgage payment will be, or the future value of your 401k account when you retire. But with any time value of money calculation, in order to get your answer, you need to specify 4 other inputs. So you can approach any problem by considering the existence of 5 potential inputs, and you simply indicate the 4 that you're given, and then solve for the remaining parameter. Let's go over each of these. Number 1, the discount rate, which is basically the interest rate that is relevant to the situation at hand. Sometimes these are obvious, like the explicit interest rate a lender gives you on a loan. Sometimes interest rates are implicitly determined by market forces, such as those for bonds. Fortunately, for homework purposes in this, and I'm sure your other classes, you're pretty much always just going to be given the discount rate to use. One last note here, the discount rate is a fundamental lever that influences the time value of money. The bigger the discount rate, the more a future dollar is discounted, or in other words, worth less in today's terms. Another important input is the length of time that the cash flows will be discounted or compounded. While this input is mostly straightforward, it is critical that you correctly determine what the unit of time is that you're working with. At what point in time does the interest actually compound? For example, if you have a 30-year mortgage, you might be tempted to say that you're working with 30 periods. But you don't make annual payments on your home. These are structured to be monthly, with interest accruing each month. So the number of periods is actually 30 times 12. 30 years times 12 months in a year is 360 months or periods. This same concept relates back to the discount rate. A lender is likely going to quote you an annual discount rate, but you need to be sure to express that rate in terms of the unit of time that corresponds to when payments are made and interest compounds. Next, we need to indicate the size of any equal recurring cash flows, and the term we use for this is payment. Now, not every time value of money scenario will have a payment. For example, if I want to know how much money I'll make if I put a chunk of money in a CD account, what will its balance be after 6 years? Even though interest might accrue each year, the only time I put money in the account was at the beginning, so there is no payment. If I were to solve this in Excel, I would need to explicitly state a payment size of 0. We can't just ignore it. You can see I've also put asterisks by this input to note that to get a precisely correct answer, it's also important to indicate whether these payments occur at the beginning or end of each period. For the most part in this class, I'm going to reduce that complexity by primarily giving you scenarios where payments occur at the end of the period. But this is something you should always carefully consider. Okay, 2 more, almost there. Next we have the present value. Often, this is the parameter we're solving for. We want to know what a stream of future cash flows is worth today. But it can also be used to calculate other parameters if you know what cash flows, if any, are taking place in the present. Lastly, future value. Again, this might be the thing you're solving for, but it can also be a cash flows value in the future. For amortized loans, where you're paying off principal amounts with each payment, this will be 0. For forms of debt that have just interest payments, this will be the principal amount of the loan. Okay, so I hope you've memorized all of that. Nah, just kidding. If some of this went over your head, we have lots of time to keep reinforcing these concepts as we work through some practice problems. Lastly, I've included in this table the various Excel functions you will use to solve for any individual parameter here. And as a quick note, in this class, we are only ever going to solve for payments, present value, and future value. But I want you to be aware that given the sufficient information, you could also solve for the discount rate or number of periods as well. One last thing to point out, there are various methods to solving these problems, and you might get exposure to all of them during your time here in the business school. For example, in a finance class, they might force you to open the hood of the car to look at the engine, the actual mathematical formulas for these calculations. Don't worry, we won't do that in this course. Some faculty in other courses might have you identify discount factors from present value tables, where you pick a column based on the discount rate and find the correct row corresponding to the number of periods. Lastly, and this was the case for me when I was doing my undergraduate work, some instructors might require you to purchase a separate financial calculator. Each of these is a perfectly feasible way of doing these calculations in school, but in this class, I'm going to teach you the best way, Excel formulas. In the future, when you're doing tasks at work, you're not going to look up present value tables, and you're not going to open your desk drawer to pull out your trusty financial calculator. Chances are you were already working in an Excel spreadsheet when you needed to do one of these calculations. You need to have a solid grasp of time value of money concepts, but you also want to be comfortable doing the associated calculations in Excel. Heck, even on the CPA exam, they'll give you discount factors if that's your preferred way of doing things. But do you know what else the CPA exam gives you? Excel. So you want to understand these time value of money functions. It'll make your life better. I realize that the topic can be a little difficult for some students, but I encourage you to really invest in your learning with this unit. It will pay dividends for the rest of your education, career, and personal finance decisions. Okay, let's review some key concepts. Money's time value results from three primary factors: inflation, opportunity costs, and risk. Remember those and how they make $1 today worth more than $1 tomorrow. Additionally, I want you to be familiar with the 5 potential inputs to any time value of money calculation. Not only that, I'd like you to be aware of some of those key additional considerations when working with each. For instance, the discount rate and number of periods require you to carefully determine the appropriate unit of time to work with, and you need to adjust those parameters accordingly. You also know that whenever payments are involved in a calculation, you need to specify whether those cash flows occur at the beginning or end of the period. Okay, really looking forward to doing a lot of practice with you.